Okay, question number 8. It says express the length of arc of the curve y equals 2 tan x from 0 to pi over 3. First thing, write the derivative down. dy dx equals, let's see, 2 secant squared. And that wasn't so bad. The next thing is basically you have to write it down, but you have to evaluate it. So it's going to be 0 to pi over 3. It's going to be the root 1 plus dy dx squared, which is going to be 4 secant to the 4th power x dx. We're done. All right, let's go to the next one. Next one, hopefully it's going to be as easy as that one. Now this one here is an improper integral, and what I want to do is just do the antiderivative first. So I would look at the indefinite integral, whoops, which is going to be ln 2x over x squared dx. I'm going to let u, I'm going to do integration by parts, natural log of 2x du. Well, it's 1 over 2x times 2, which is 1 over x dx. Then I can put dv down, and dv is going to be 1 over x squared then. It's forcing me to do that, dx. And then v, well, that's x to the minus 2, so increase it by 1, minus 1 divided by 1. So it's minus 1 over x. And there's some constant integration. We're going to worry about that later. So this guy over here doing integration by parts is going to be equal to, let's see, have to be careful with this. So minus the natural log of 2x over x. That's the uv part right over here. Let's see, minus, let's see, that's going to be v du. So minus of minus 1 over x, plus 1 over x, and then the du is 1 over x dx. All right, looks pretty simple to do. This is minus the natural log of 2x over x. This guy over here is just simply, 1 over x squared, which is x to the minus 2. So I'm going to get minus 1 over x. Let me just check that. That's x to the minus 1. That would give me plus, yeah, that looks good. And then plus some constant integration, which I really don't need to worry about. This is an integral that has limits on it. So I'm going to go back to my original limit. Limits of integration, 1 to infinity, natural log of 2x over x squared dx. I'm going to write the antiderivative down now. And the antiderivative is going to be minus the natural log of 2x over x minus 1 over x. And we're going from 1 to infinity. Now, I'm going to write the limit down. Not that you have to do it, but I do want to write the limit down for you. It's going to be a limit. This is equal as a goes to infinity. And let's write this down. So it's going to be, let's see, minus the natural log of 2a over a minus 1 over a. And then we get minus a minus now, and I'm going to evaluate the 1. So it's going to be plus the natural log of 2 over 1. And then I'm going to do the next one, which is minus a minus, is going to be plus 1 now. All right. Now, again, I wouldn't go to L'Hopital's rule here. The bottom in both of those limits goes faster than the top. So it's going to be 0 there. So I'm left off with a natural log of 2 plus 1. All right. You can also write down 1 plus the natural log of 2 if you want. Let's go to the next question. The next question is going to involve, looking at it. I'm going to say telescoping series, partial fractions. And let's write this down now. So I'm going to do the partial fractions first. Let me write this as, 1, 5n plus 4. That's going to be, I don't know, over 5n minus 1 plus, I don't know, over 5n plus 4. Clear the fraction, you get 1, a, and then you get 5n plus 4 plus b, 5n minus 1. And again, like I say, you're always free to choose what numbers you want. The numbers I'm going to be choosing, I'm not going to choose fractions, but you're more than welcome to do so if you want. I'm just going to choose like n to be 0 now. And what would you get? You get this. This would give you a pretty simple statement. 1 equals, if n is 0, you get 4a. and then you would get minus b. And then I would choose n equals 1. Again, I'm choosing numbers I like. You choose your own numbers. This is 1. And then what do you get there? Let's take a look at that. If I chose 1, I would get 9a. And then I would get plus, let's see, 5 minus 1 is 4, right? 4b. So I'm going to multiply this one by 4. And what would you get? You get 4 equals 16a minus 4b. This is like going back to Math 100, what you did in Math 100, elimination. 9a plus 4b. Add them together. What do you get? 5 equals 25a. And a here is pretty simple. It's just simply 1/5. All right? Let me cross this out, put 1/5 down over here. Now, someone says, how do you get the other one? I'm just going to plug it in. All right? And we're going to plug it in. I don't know. Let's plug it in this one here because it looks pretty easy to me. All right? So let's write this down. You get 1. 4 times 1/5 is 4/5 minus b. I want to subtract 4/5 from both sides. That would give me 1/5 equals minus b, which means b is equal to minus 1/5. All right, I'm going to put my sum down now. And as I do it, I'm doing what's called an nth partial sum. I'm going to be starting at 1. And we're going to do this uppercase n. And I can put my partial fraction down. I notice about it that 1/5 here, I'm going to factor it out. I'm going to put the 1/5 here. And then the first term is going to be 1 over 5n minus 1. And then it's going to be minus 1 over 5n plus 4. Okay, let's write this down sort of like as an expansion problem. And you're going to see a pattern immediately. It's not going to be a tricky thing. You can get 1 over something, minus 1 over something. Every term looks the same to me. 1 over something, minus 1 over something. 1 over something, minus 1 over something. And it keeps going and going and going with dot, dot, dot over here until we get to the end, 1 over something, minus 1 over something. Whoops. So let me talk about the something. And I'm going to chase one route at a time. If you start at 1, the first denominator would be 4, right? And then it's going to go up by 5. And that doesn't seem so bad to do, by the way. 9 goes up by 5, and then you get 14. And I certainly know it goes up by 5. Look at the next one. If I start at 1, what do I get? Let's see, you get 5 plus 4 is 9. It goes up by 5. That would be 14. Goes up by 5. That would be 19. And then in the end, what do you get? You get 1 over 5 big N, let's see, minus 1, and 5n plus 4. Let me go back and look at that. Yeah, okay. What do I notice? It's telescoping, and by that I mean it's just simply canceling off. That there be something there to cancel off, and there's actually something there to cancel off that. All right, something there. Because they go back by 5, you get 5n minus 1 there. So the nth partial sum's really kind of easy, and it's going to be 1/5. Make sure I'm writing that down right. And then what do you get? You get 1/4. I'm just copying what I'm seeing over here. I'm looking at the partial sum. Minus 1 over 5n plus 4. And that's what's known as the nth partial sum, Sn. All right? So once you get this Sn business, what you need to do is you need to take the limit as n goes to infinity. Now, when I say n goes to infinity, the big N goes to infinity of Sn. And that's a rather easy limit to do. You just get 1 over 20. Whoops. 1 over 20. All right, let's go back up here. And that's exactly what we just did. We just did this thing over here. And it's going to be 1 over 20. All right? All right, that one's done. Let's go to the next one. Next one's a review of Calc 1. And I have to do a derivative over here. And let's take a look at this. dy dx equals... I got to. My handwriting's not being recognized properly, so that's why it's trying to do that. By the way, but let's not worry about that. So tan x, secant x, then it's going to be plus 2 sine x. Okay, I need to know what dy dx is. This is a tangent line at pi over 3. All right, the way to do that, I'm going to draw a triangle for you. It's a 60-degree angle, by the way. So this is the pi over 3. And this is going to be 2, 1, root 3. Let's write this down. The tangent is going to be root 3 over 1. The secant is going to be 2 over 1 plus 2 times the sine, and the sine is going to be root 3 over 2. This is rather simple. I get, let's see, 2 plus 1, which is 3 of those root 3's, and that's a slope. They gave me the point. I'm pretty easy to write an equation down now. It's going to be y minus y1, which is 1, equals the slope, 3 root 3, and then it's going to be x minus pi over 3. There's really no need to multiply that, but if you want to, you can. All right? That's going to be the equation of the tangent line at that point to that curve. So y minus 1, 3 root 3 times the quantity x minus pi over 3. All right, that was not a bad question. This is a Taylor polynomial, and it reminds me of the question I was asked in class the other day, and this is so typical. I'm saying we're given low-hanging fruit over here. The first thing I do is write derivatives down. So f of x, and that's going to be x4 minus 2x, take a derivative. That's 4x cubed minus 2. Second derivative, and that's going to be 12x squared. And then I go to the third derivative. And that's going to be, let's see, 24, right? X squared. All right. What do I do now? Evaluate. And again, I don't think arithmetic's difficult, but if you have trouble with it, try to practice. Let's see, 3 to the 4th power is 81 minus 6, and that's 75. So f prime at 3. Well, that's going to be 27 times 4, which is 108. Let me just make sure of that 27 times 4 is 80 and 27. Yeah, 108 minus 2, that's 106. Let's do f double prime at 3, and that's going to be 12 times 9. That's 90 and 18, 108. Right, not so bad. F triple prime at 3 is 24 times 9. I made a mistake there. I just noticed it. And I thought the arithmetic was getting really tough, wasn't it? Let me erase this. I'm glad I thought about the arithmetic before I did anything. This is going to be 24. Get my eraser out and erase this thing over here. Then I started thinking that number just doesn't look right there. That's why I look back over it. So let's take a look. And what do you get over here? You're going to get 24 times 3, which is 60, and 12, which is 72. All right? So what do I do now? I'm just going to write the Taylor polynomial now, T3. Let me make sure that's what they asked for. They did. And the way I'm going to do that, just the way I've always been doing it, certainly we have a pattern for it. And before we got the pattern, we did a bunch of examples to think our way through the patterns. 75 plus 106. The center, again, I got to remind myself, was 3. So x minus 3 plus, let's see, I did that. Now it's 108 divided by 2, which is 54. And then x minus 3 squared. And the last term is going to be, I'm on 3 now, which is 6 factorial. This is x minus 3 to the 3rd power. And 3 factorial 6, and 6 goes into 72 12 times, because 6 times 12 is 72. So that's T3. All right, let's go to the next question. This is a geometric sum. It's convergent. And the reason it's convergent is that common ratio there is minus 2/3. So I'm going to write down the first, the A, the first term. That's going to be 5. And we're starting at 2, so this is going to be minus 2/3 to the first power by, because 2 minus 1 is just the first power. And the common ratio R is going to be minus 2/3. Again, putting the formula down, the formula is going to be the A, which is 5 times minus 2/3, and then 1 minus R. What's R? 2/3. So it's 1 plus 2/3. I'm going to multiply top and bottom by 3. And yeah, you should do the arithmetic. The bottom would be 3 plus 2, which is 5. I probably shouldn't have even... let me go through it again. So the 3's cancel, you get minus 10. And minus 10 divided by 5 is minus 2. A little box in that. That one's done. This one is probably, for a lot of students, the toughest question on the exam. But again, I want to encourage you. And I realize a lot of students don't really, I always say they're not really putting in what we consider to be the proper effort, and that is, studying. What do you study? I would say low bar of achievement is to study what we give you, the notes. I mean, certainly if you're at a university, they might give you notes, by the way, but they would expect that you'd also read the textbook, do all the examples of textbooks, all the problems in the textbook, and probably, depending on what university it is, exam questions would entail probably something you're familiar with if you've studied. Now, if you haven't studied, not familiar. So what I'm going to do is write down, I see SN, by the way. They gave it to me. They say that A1 plus A2 plus A3, yada, 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 all the way up to AN is something really easy. It's N plus 1 over N plus 10. So what I could do, I could look at this and say that SN is really SN minus 1. That's right over here, by the way, right? Plus AN, all right? Then what do? I write down SN, and SN is going to be N plus 1 over N plus 10. And writing down S minus 1 should be relatively simple because I have a formula for it. And what's that going to be? Well, let's see, N minus 1 plus 1 is just an N. And N minus 1 plus 10 is going to be N plus 9 plus AN. All right? All right, so what do you do now? I'm going to solve for AN. And AN is going to be N plus 1 over N plus 10 minus N over N plus 9. What I'm going to do now, common denominator, that's N plus 10, N plus 9. You do some, basic algebra skills. Let's see, it's going to be N plus 1 times N plus 9, which is N squared plus 10N plus 9, and then minus something. Let me check before I do that. It's N squared. I get 9 plus 1 is 10, and plus 9. Then what do you get? You get N squared minus 10N. I'm sorry, plus 10N. I'm going to subtract, and it looks pretty nice, by the way. It looks like 9, and then bottom I'm going to multiply it out. You don't have to, but it's N squared 19N plus 90, and that's AN. All right, so is there another question there? No, that's it. Thank you.